Sir, you are not audible.
Yeah, you can tell. Everybody will start the session maybe by 4-5 minutes. Let more people join in. Only just 15 or 16 have joined in. So I'll wait for a few more minutes. Okay.
Okay, sir. Okay.
Okay, sir.
By then you can everyone just join in through joinpd.com. Okay. Yeah, I think you can see the code over at the top
Yes,
right
sir.
corner.
Yes, sir. We aware about that.
Okay. Okay. So good evening, everyone.
Good evening,
So
sir.
today is the solve with instructor session for week 10. Okay. So as usual, if somebody is joining for the first time, then you are supposed to log in through joinpd.com, and then once you can see the questions, you can type in your answers through that portal only. And we'll be going through some questions which are very similar to your assignment questions from week 10, and we'll try to solve all those questions. Okay.
Okay,
So
sir.
I would request all of you to just, if any of you have not logged in till now, then just please log in to joinpd.com so that we can have an interactive session now. Okay, so these are basically, so as I was saying, the normal protocol would be that for each question we'll be allotting almost 3-4 minutes, and depending on the question, maybe some questions you may need more time. Accordingly, we'll see, and once sufficient number of people type in their responses, then we'll move to the solution part. Okay, so we'll start with the first. It's kind of a prelude to the main question number 1. So it's a sub part to the main question. Okay. So let's start with this one. The question is visible to all, right?
Yes, sir.
Okay. Anyone who is not able to answer understand the question, or I think only 50% have responded till now. What about others? Are you all trying? Am I audible, guys?
Yes, sir, you are audible.
You are audible.
Okay, anyone still trying, or else we'll move to the solution part?
No, sir, move to the solution part.
Okay. So basically the question says that there's a
Just one
there
moment. Just one moment. I just joined. I think
Yes.
1 by 4 plus 2 by 4 plus 3 by 4 plus 4 by 4, sir.
Sorry, are you talking about the solution?
Yeah.
Okay. Okay, so you are saying what's the answer? Can you just repeat it once more?
Expectation 1 by 4 plus 2 by 4 plus 3 by 4 plus 4 by 4.
No, not exactly. Okay, so basically, first thing is, can you tell me the probability values? Like first, let's move at one step at a time. Can you tell me what is the random variable over here?
1, 2, 3, and 4.
Okay, means what would be that quantity called? Like, okay, the values it can take maybe 1, 2, 3, 4. Like it's talking about
numbered ball.
correct. So we are talking about the number in the ball at the top of the ball, right? The
You're right.
balls are, and they are numbered 1 to 4. Now, what would be the probability? Each ball means picking up any ball. Let's say, can you tell me what is the probability of picking up ball with number 1?
Yes, sir.
So what would be that probability value?
1
1 by 4.
1 by 4, yeah.
And let's say what would be the probability value of picking up a ball of number 2?
1 by
2
4.
1 upon 4.
1 by 4.
But it is
Okay.
given
Actually, sir,
proportional to the number on the ball.
Yes, exactly. So
2 by
means
4 it will be, I guess, 14.
those people who are saying that it would be
2
1 by 4, I think you
Yeah.
should reconsider this part, the last part, that is probability of drawing a ball is proportional to the number on the ball. So what should be the probability value?
It should be 0.1, 0.1 for 1, 0.2 for 2, 0.3 for 3, and 0.4 for
0.3, like how are you finding out 0.3? It's 3 by 10, right? 3 by 10.
Yeah, that's what. So
Not exactly that way.
2
It is
2 by 4, 3 by 4, and like this, sir.
it is talking
Sir,
about
it's
proportional. Yes.
1 by 8 for 2.
For 2 it is 1 by 8, and what's the logic behind it?
Sir, 1 by 4 and the number in the ball is 2, then 1 by 2. 1 by 4
See,
into 1 by 2 and 1 by 8.
I'll tell you one thing. When we are talking about proportionality, we don't know exactly what is the constant value, right? For example, when we say C is proportional to, let's say, X. Okay. So we can just say that there will be some means there will
Right,
be
sir.
some
Sir, like C
multiple-
proportional to K, so it will be C equal to KX or like something.
yes, X multiplied by K times, right? So over here we are talking about proportional to the number on the ball. So my number, whatever the probability value would be, let's say we'll consider it to be X. Now for a first case, that is probability of, let's say the random variable is X. Okay, sorry. The random variable is X, and let the probability value, let's say, be small p. Okay. So probability of X equals to 1. We can just write something like it is proportional to the number on the ball. Correct. So you can just write it means K, if you have taken K or let's say small p, then it is just equals to P. For probability of X equals to 2, we can write it 2 into P times, means 2 into P. And for probability of X equals to 3, we can write it 3 into P. And for probability of X equals to 4, we can write it 4 into P. Is this clear to all?
Yes, sir.
Because we are talking about the proportionality, right? So we'll just multiply that constant terms. That is, and what we are multiplying with which constant number? That is the number on the ball. Now we'll be using one more property, that is that when you are talking about a distribution of a random variable, what are the two properties or the properties of PMF? Can anybody tell me?
Sum of all the
Should be
probabilities.
positive and greater
Yeah,
than someone.
correct. So each probability value should be greater than 0, and the second one should be they should sum up to 1, right? So over here, none of the p values, one condition we will put that none of the p values would be less than 0. That is, all should be positive numbers. And the second one should be that p plus 2p plus 3p plus 4p equals to 1. Is this clear?
Yes, sir.
Sir,
So let me move. Okay, this We move to the solution slide also. Okay, so they've taken K. So from this part, as I was talking about, that X, this in the top part, if you see 1, 2, 3, 4, this is what, this is the range of the random variable, that or the possible values X can take. Now for this is the PMF we have tabulated in a tabular format, right? So for the first case it is K, for the second case it is 2K, 3K and 4K. And now we'll be using the PMF property and we'll sum it up all to 1. So from there we'll get a K value. Now that is what? That is my proportional constant of proportionality with which I'll be multiplying each term, right? That when we are talking about that it is proportional to the number on the dice, the number on the ball. So this was the proportionality constant that we didn't know, that how much we should multiply each value. So that's why we took it a normal variable K, and then we use the property values, the properties, and we try to find out that proportionality constant value, and that comes out to be K. Now this K is the proportionality constant, and now we can easily find out these probability values for each term. That is, we'll just multiply each, and then you are getting this 0.1, 0.2, 0.3 and 0.4. Once you get this, then it becomes just a putting the values and then finding out the answer for the expected value of the random variable. That is, we'll go with the random variable value multiplied by the probability of that taking that value. So it will be 1 into 0.1 plus 2 into 0.2, 3 into 0.3 similarly. So you can just consider it this way also. I think it was also taught in the lectures that if you are from a physics background or something, that whenever we used to find out moments and all, we can just kind of consider it that way, that this is the particle and this is the weight for that particle. So these are the, you can consider these to be kind of weights. So 0.1 is the weight for 1, 0.2 is the weight for 2, 0.3 is the weight for 3, and 0.4 is the weight for 4. And you can just multiply them and you will get the expected value, that is coming out to be 3. Is this clear to all?
Yes, sir.
Yes, sir.
Anyone, any doubt?
No, sir.
Okay. Okay, so we'll move to the next one. Okay, so this is the full-fledged question for which we suppose solve the sub part of this question. Can you tell me like how is this question different from the last part which we were talking about?
So in the previous one, we were drawing a single wall.
Yes.
Here we are drawing 3 balls. And in the previous one, we were only taking the number on the ball. Here we are talking about the sum of the numbers on the ball drawn.
Yeah, so in this random experiment, the difference is 2 things. One is over there we were picking up 1 ball at random. Over here we are picking 3 balls at random. Over there my random variable was whatever was the number on the top of the ball.
Here it is sum.
Yeah, over here we are summing up all the numbers that will be getting consecutively in the 3 draws. Okay, so that would be my final random variable. Now similarly, you can find out the range, what would be the possible range for the random variable, and then the expected value. Did everybody understand the question?
Yes,
Anyone
sir.
any the question?
Solve.
Okay. Only 7 have responded till now. What about others? Like, are you trying it or you're confused with the question? If you're not understanding the question, you can ask so that maybe I'll give you some clues to move ahead. But everyone just try to solve the answers as much as possible. Even if you're giving wrong responses, doesn't matter, but even at least try. Okay, so anyone still trying or else we'll move to the solution? Okay. Okay, there's a lot of variety of answers. 0.14, 7.5. Anybody would like to explain like what should be the approach for this question?
Sir, the sum of the balls we choose can come out to be 6, 7, 8, and 9. And the probability of each is going to be 0.25. So,
Okay, so now
that was my approach.
First tell me what should be the possible values the random variable can take.
6, 7, 8, 9.
Okay, so yes, let's say for the first ball you are getting 1.
Yes.
And then for the second ball you are getting the minimum possible number can be, it is 1, 2, and 3, right?
Yeah. 1, 2, 3.
Okay,
So that is
that
6.
way, okay. And the
And the
maximum possible.
maximum would be 2, 3, 4. That is 9.
Okay.
So 6, 7, 8, and 9 are the possible sum that we can get from these balls. And for each, the probability is 1 by 4. It's 0.25. So after that, it's just calculating the expectation.
Okay, so how much you are getting from that way?
7.5.
7.5. Okay. Anyone else like any other method? I think some 7.5 would be around this. Okay, 7.5. Somebody said 7.66 also. Somebody also said 9. Like, who are these people? Can you just explain your approach?
Sir, I got 7.66.
Okay. What's the method?
I took the random variable as x values as 6, 7, 8, 9. And it says the probability is the proportional. A ball is proportional to the number on the ball. So I took a 6K, 7K, 8K, 9K. So K value I got 1 by 30. So expectation I got as 36 by 30 plus 49 by 30 plus 64 by 30 plus 81 by 30. Total 230 by 30 giving 7.66.
Okay. Okay. And what about who said the 9? Who gave the 9 response? Can you just explain your method? Seven point 7.66. Okay. Okay, I don't know. Okay, the first thing is about the 7.66. See, the mistake you are doing for 7.66 is that we are talking. If you read the question once more, that it is talking about the first part is okay, but for the second part, we are talking that it's a group of 3 balls drawn at random from the box. Then what is the expectation of the sum of the numbers on the balls drawn? So we are consider over here, my random variable is the total sum. That is okay. You all are doing, let's say we are saying what are the possible values x can take. If my values were 1, 2, 3, and 4, then you are saying my x can take from starting from 6, then 7, 8, and 9, right?
Yeah.
Okay, first thing is 6 I understood. That is you are saying for making 6 you will need 1, 2, 3. Now
Yeah.
how will you make 7? It would be normal.
1 to 4.
1 to 4.
1 to 4. For 8 it would be
1, 3, 4.
1, 3, 4. Okay. Is there any other?
9, 2, 3, 4.
Okay. For each, is it only single combination that's possible? Okay. So first thing is that I think what the last person was who was saying that 7.66. What you did over here was that what was the probability values you multiplied? It was that you are saying that it is proportional to the numbers, right? So you took it to be 6K and then 7K this way something, correct?
Yeah. Yes.
So we are not talking about the sum of the probability means numbers on the ball, that is it is proportional to that number. Okay, we are talking about only the it is proportional to the number on the top of the ball, and you are connecting it to the proportionality of the sum of the numbers. That is, my 6 is not the number that is available on the top of the ball, right? It is a number that you are getting by summing up all the numbers that you are getting on each ball, correct?
Okay, sir. Okay.
So that is the mistake in that approach, that will not be able to do it. That means the random variable probability, we can make it proportional to the number or the sum of the numbers of the random variable, means each random variable or number on each ball, whatever. And I think the other approach what you are talking about, that 7.5 thing over here, you are saying that the number the mistake is that you are considering each ball probability to be 1/4, right? Whoever said that 7.5, who was that?
I was it.
Okay, so you consider it to be the probability of picking up each ball is 1/4, correct?
Probability of getting that sum is 1/4.
Okay, so let's say, for example, probability of x equals to 6. What would be that value? Can you tell me?
1, 2, 3.
0.6, sir.
Okay, whoever is saying 0.6, how are you saying, how did you get into this 0.6 value? And I think Chetan, how did you get x equals to 6 as 0.4? Sorry, you said 1/4, right?
1/4.
So 0.25, how are you getting?
So there are 4 ways I can choose the balls: 1, 2, 3, 1, 2, 4, 1, 3, 4, and 2, 3, 4. From which of these combinations can I get 6 as my possible sum? So that is only one way. That is why I did 1/4.
No, the fundamental problem what happened over here is that the thing you are considering, that would have been the case if you would have said that each ball picking up each ball was equiprobable, or uniformly we can pick up each ball.
Got my mistake.
But the base thing that you messed up again is that probability of x equals to 1 was not equiprobable with x equals to 2.
So
It
for
was
1, 2, 3, it should be 0.1 into 0.2 into 0.3 divided by.
If you see, if I go to the last slide, over here we have already got these values, right? That's 0.1, 0.2, 0.3, 0.4. So if you are going in this method, that 1, 2, 3, then for each you have to consider this probability value. That is, for probability of x equals to 1, it would be 0.1 into for x equals to 2. It would, okay. So that was the mistake. Now, okay. So this is also not the right one, but the correct answer, I don't know whoever was that. It was supposed to. Okay, now that response isn't there also. Okay. So the correct answer. Sorry.
Is it 23?
No, it's not 23, but the correct answer would be 9. Okay. So the easiest way to do this is that we will divide this thing into 3 random variables. Let's say x equals to 1, x equals to 2, and x equals to 3. That is, we are picking up 3 balls, correct? So let's consider it that way. Okay, just give me a second. Okay, sorry for the delay. So where I was, see, we are talking about that picking up 3 balls, right? So 3 balls, you can consider it that each ball can be one random variable. Like initially what we were doing, that we were only picking up 1 ball, right? And that was, I was considering it to be one random variable. Now, if I'm picking up 3 balls, I can also consider that the first one is one random variable, second one is another random variable, and the third one is another random variable. And then I can, on top of these 3 random variables, I can declare another one random variable, which would be the sum of these random variables. So let's say my picking up first ball is a separate random variable x1, picking up second ball is a separate random variable x2, and for the third one x3. And now for the sum of the random variable, numbers on the balls, I will declare another random variable, let's say y. Now, so what would be my y? It would be x1 plus x2 plus x3. Now, from the first question, the previous one, we have already find out the expected value for one random variable, right? That is e means expected value of x1. We have already got it to be 3. Is this okay to all? So if we do it x1 plus
Please
x2
explain
plus
again, ma'am.
see, in the first question, I was picking up only 1 ball, right? And over here, I'm picking up how many balls? I'm picking up 3 balls. Is this clear?
Yes, ma'am.
So can we extend the first question to the second question? That is, the first question was, I am picking up 1 ball and I was defining it as one random variable. And from there, I was finding out the expected value. So for this question, I can make it extended to 3 random variables. Let's say picking up first ball, I'm defining one random variable for that. For picking up second ball, I'm picking up defining another random variable for that. And picking up the third ball, I can define another random variable for that. So basically what I am doing, the second question, I am dividing it into 3 parts. That is, means the first question, I'll be doing it 3 times. Kind of, you can say it that way. That is, for the first ball, I'll have one, my first ball, picking up my first ball would be similar to question number 1. My second ball, again, it would be similar to question number 1. And the third ball, it will be again similar to question number 1. And then on top of these 3 random variables, I will add them all and I will get the sum of the numbers that I'm getting from each random variable, or that would be my new random variable. That would, I can declare it to be y. And then from there, property wise, if you say that it expected value of y, I can just declare it expected value of x1 plus expected value of x2 plus expected value of x3. If I move to the solution part, I think that would be more clearer. See, so over here, xi we are talking, my I would be the ball I am picking up on the, maybe if I equals to 1, that would be in the first try, or in the first draw. I equals to 2, I will be picking up the second ball. I equals to 3, I will be picking up the third ball. Is this clear? And from there, expected value of x1, I know 3 because I have already calculated it from the first question. And similarly, it would be the same value for x equals to 2 and x equals to 3 also. And then on top of these 3 random variables, I'm declaring another random variable y. And then from the property of expectations, I can just tell it that it would be expected value of x1 plus expected value of x2 plus expected value of x3, or I can write it 3 into expected value of x. That would be 3 into 3, 9. Anyone who didn't get this part? Or is it clear to all? Guys, am I audible?
You are audible, sir.
Actually, I have a doubt.
Yes, sir.
If we are drawing the balls, then how the expected value of every random variable is same?
Okay, so see, when we are talking about one random variable, I think was this taught in the means week 10, this identical IID samples, that is identically independent variables? Was
Actually,
this there?
Uniform
to
discrete
ask-
random variable was taught.
Okay, so I'll tell it. So basically what it is that we are considering the same ball, right? For example, means my experiment is always the same. 3 times I'm doing it. I can pick up one ball from the, let's say there is a basket and inside that there are 3 balls, 1, 2, 3. Or 3 balls or 4 balls, whatever it was. Okay, there are 4 balls, 1, 2, 3, 4, right? So now each time I pick up the ball, that is, I can consider it to be one simple experiment, right? And I can consider it that the same experiment, I'm repeating it 3 times. Now for each experiment, I can define the random variable, the X, and that X can take, random variable can take the values 1, 2, 3. Right, and that experiment I'm just repeating it 3 times, that in each experiment what are the values possible. So for each experiment I'll get one expected value, right? So that's
got it.
that is why, because this experiment is same, the ball, the basket is same, the balls are same, so these are identical experiments and they're independent of each other also. Means whatever happens in my first trial, it doesn't matter, again I will pick up in the second trial some ball, in the third trial again I'll pick up some ball. Is this clear? Is this clear to all?
Yes.
Okay. Okay, so I think there was one, I think Chetan. Did you get the answer from whatever method you were saying? Chetan, are you there? Okay. Okay, I think he is in there. Okay, so we'll move to the next question. So this part is clear basically. I think that one thing is
Hello.
each.
Hello. Am I audible, sir?
Yeah. Mhm.
Some
Yeah.
my audio was having issues. No, sir,
No
I didn't get the answer. I tried with my
okay.
method. I didn't get the answer.
Yeah. So can you, after the explanation, can you tell like why are you not getting the answer? Because see, one thing, you were considering it to be one whole experiment to be one. Okay, that is what,
Yes.
that if you pick up one ball, that is, let's say you picked up the first ball to be number 1. Okay, so you were considering indirectly that in the second pickup I will not get number 1, I can get only number 2, number 3 and number 4, right?
Correct.
But that is not the case over here. We are considering each trial to be, or each draw to be independent of the other draws. Okay.
Okay.
That is what the main idea is, that in the first draw also you can pick up one, in the second draw also you can pick up one, means you have the chance of
So the
picking up one.
question says that if a group of 3 balls is drawn at random from the box, so we are picking up the group, right? So intuitively, one would think that we are not successively pulling the balls out, but in a group we are pulling out the 3 balls.
Correct. See, if we are talking about that, this the group of 3 balls are picked up together randomly or consecutively, there would be some wordings given over there. Now over here, what you are talking about, that the group of 3 balls are picked up because I think I mentioned it, that it's a subpart. The first prelude was a subpart to this main question, right?
Yes, correct. You mentioned.
So the question was framed in such a way that we are having one ball and then independently we are picking up. Maybe you took up over here. We are not considering also that without replacement or with replacement, anything is not given over here, right?
Yes.
So it is like we are considering that one ball has been picked up and then you keep it inside that bag maybe, or basket, whatever it, and then independently again you are picking up another ball, and then independently again you are picking up the third ball. Okay.
Okay, so in that case, if I were to do it with my method, the number of values that a random variable can take increases.
Maybe because you will add on some cases. Let's say, for
Yeah.
example, you can have two means 3 twos also, right?
Correct.
So that way you will increase some cases. That
Yeah,
should-
got it. Got it.
okay. So I'll move to the next question. Yeah, this is a very simple one. Just you have to use the concept of function of a random variable and then find the expected value of that. Everyone, please try the questions, and if you're not even understanding like what are expected values or any conceptually you're not getting these things, you can ask. I'll try to explain those parts also.
Sir,
Yes.
excuse me, sir. Sir, for me the
Yeah.
page isn't loading. Maybe there is problem in my Chrome or I don't know, sir. I'm just solving in my paper and checking the answers, sir.
Okay,
Is it
okay, no
okay, sir?
issues. Yeah, sure. Okay, anyone still trying, or shall we move to the solution? Okay.
Answer.
Okay, there are a lot of various different responses. Anybody would like to explain like what should be the way to solve this? Anyone?
So there is a function x square plus 3. So this x minus 1, 0, 1, 2, you applied that function and it became 4, 3, 4, and 7. Then you found the e of that function. So which is
Correct.
8.8.
See, for example, like if you see the last question also, when we were doing y equals to x1 plus x2, x3, we could have said this y has to be a new function of these three variables, right? Which was taking these three variables as input and the function was summing them up. Over here also, it is nothing. It's the same way. We have just given a different name to it, g of x. It can, you could have given it y or something, and that it would have been that over here, the function has changed to be x square plus 3. That is the only difference. And then this new random variable, how we will give assigned values to it, we'll just put this normal x values, right? So for first, it would be minus 1 square plus 3. That would come out to be 4. So if I'm in giving input as minus 1 to my random variable x, then this g of x, or let's say y, whatever be my new function or new variable, that value would come out to be 4. Similarly, for if you're putting 0 in the place of x square, then it would come out to be 3. And for again, for 1 also, it would come out to be 4. And for 2, it would come out to be 7. Right. So can anybody tell me what should be the range of gx, or let's say the new variable be y or whatever it is? What are the possible values?
3, 4, 7.
Sorry?
3, 4, 7.
3, 4, 7.
3. Okay, yes. And then we'll just find out the probability values of this thing. So if you see over here, you can see this, that we are considering that g of minus 1 and we are getting 4 over here, 3, again 4 and 7. So now if you have to find out, and this is the range as we are talking about, that it would be 3, 4, 7. And now if you have to find out individually the probability values of this new variable g of x. So can anyone tell me what should be the probability value of 4? Or the PMF of
0.4.
0.4. Okay. So how are you
0.3 plus
calculating?
0.1.
0.3 plus 0.1. That is for x equals to 1 and x equals to minus 1.
Minus 1.
So
Correct.
we'll take both the values and then we'll sum them up. Anyone who didn't get this part? Is it clear to all?
Yes.
Okay.
So if we
So-
were to
Can
do
you
it,
repeat the PMF part?
So the PMF part is, see over here we have the PMF for x, right? And it is already given to us 0.1, 0.15, 0.3, 0.45. And now top of this random variable, we have defined a new random variable or a new function that, let's say it is y or g of x, and that is x square plus 3. So now we will put all these x values and we'll try to find out the values for the new random variable. So when you put these values, let's say x equals to minus 1, what would be my g value or g of minus 1? It would come out to be 4. Similarly, you can do it for 0, for 1, and for 2. And the new values which you will be getting are this 4, 3, 4, and 7. So now for us, this new random variable is this, that is g of x is my new random variable. And what are the possible values g of x is taking? It is taking 3, 4, and 7. Okay. Now, if we have to find out what are the possible values this random variable or the probability or the PMF for each values of this random variable, we can just map it to the previous random variable. Like for example, if I have to ask you the probability of g of x taking value 4. So what are the possible ways gx can take 4? It is either we have to give x equals to minus 1 or I have to give x equals to 1. Right. So giving x equals to minus 1, what was the probability value for x equals to minus 1? It was individually 0.1. And similarly for x equals to 1, it is again, I think, what was the probability value for x?
0.3.
0.3. Okay. So we'll sum both of them because these two values can individually give me 0.4, value of gx to be 4. So I will just sum up both the probabilities, and that would give me the PMF or the probability value for this new random variable, taking the value as 4. Okay. Similarly, we can find out all the probability values, let's say for 3, 4, and 7, and then we can find out the expected values of them by multiplying similarly. That is 3 into some probability value, 4 into some probability value, and 7 into some probability value. So that would be one approach. Now, can somebody tell me what can be another approach to solve this question?
So we can find out the expectation of X and
Okay, so
there is another way of using those properties, but I don't know exactly how to do it.
No, yeah, exactly. The thing is that this, as I was talking about, this is a new random variable. You can think of it, right? Or expected value of gx, if you see in the question, or expected value of, let's say, y, whatever it is. Now, from the expectation properties, we know that if you have been given that expected value of x1 plus x2, like we did it in the last question, we can divide it out to be expected value of x1 plus expected value of x2, right? So over here also, if I write expected value of x square plus 3, I can divide it into expected value of x square plus expected value of 3. Is this step clear to all? Is this clear to all? Or anyone who didn't get this part?
So if it
Yeah, the second
check the
option is
expected
not
value of X, that would be -1 multiplied with 0.1 plus 1 into 0.3 plus 2 into 0.45.
I think expected value of x,
And
okay, we
summing it,
didn't find it. No, expected value of x we don't need, right? We need expected value of x square, correct?
yeah.
So you will just first multiply, means square those values, that is -1 square, 0 square, 1 square, 2 square, and then you will multiply with the probability value. So what ultimately for the expected value of x square, it would be 0.1 into 1, 0.15 into 0, 0.3 into 1, and again 0.45 into 4, because the value would be 2 square, right?
Yeah, correct.
So that would give me the first part, that is expected value of x square. Now the interesting part is, what should be the expected value of 3? Can anybody tell me? What can be the expected value of 3?
3?
1, sir. No?
3?
Expected value of 3. 3 is 3.
Yeah, expected value of any constant would be 3, means that constant itself.
Constant value. Yeah.
Okay. So these are, I think these are the properties that were also discussed in the lecture. So using the properties also, you can solve this question, or you can do it in the normal method, which will I'll show you through the slides also. That's the first method which we discussed. Accordingly, you can solve this method also, or through the properties of expected value also. Is this clear?
Yes, sir.
Anyone, any doubt in both the methods? Okay, so I'll move to the next part. So this is the prelude to question number 3. The first part is very simple one. I think from week 7 or something, you can just use those concepts and do the first part.
Yes.
So everybody, please try to solve this. Okay, anyone still trying, or we'll move to the solution? Anyone who needs more time? Okay, so we'll move to the responses first. Almost. Okay, I'll give you maybe 30 seconds more to just check your answers on, because from whatever the responses are, only one person has given the right answer. All others responses are not right. So you can just check your calculations. Maybe you have 30 more seconds to change your responses. Out of all the possible values, one is the right one. So you have to find out what is the probability of that right answer and try to click on that. Solution part of this. Okay, would anybody like to say what can be the approach for this? Anyone, any idea? We have already discussed this in the previous weeks. See, there is a box of 10. Tell.
Sir, we have to find one dark chocolate out of two. So first of all, the favorable cases are
1C2.
4C1 and 6C1 and plus 4C2, and the total cases was 10C2.
Okay, so over here the problem is that if you read the question, it is saying that find the probability that one dark chocolate is drawn among those two randomly drawn. Okay, so you don't need that 4C2 part in the in the second case which we are adding up, right? In the favorable case, because it is not given that at least one dark chocolate. Whatever solution you are talking about, it would have been correct if the question would have been that find the probability that at least one dark chocolate is drawn among those two randomly drawn chocolates. But over here it is given exactly one dark chocolate. So my favorable cases would become 4C1 into 6C1.
4 into 6.
Is this clear? Whoever was saying the answer?
Yes, sir.
Understood what's the mistake?
I got it.
So it would be 4C1 into 6C1 divided by 10C2.
0.532.
Okay. So this would be the solution to it. Anyone who didn't get this part?
How it is
Got it.
6C1? Why are we multiplying?
See, because when we have, if we are picking up two chocolates and we are saying that one has to be the dark chocolate, then the other one has to be a milk chocolate, right? Because those are the two types of chocolates that were available to us. So if we are taking the first one has to be a dark chocolate, that is 4C1, then the other has to be a milk chocolate. And how many milk chocolates do we have? We have 6 chocolates, and out of those, we have to choose one of the 6. So that would be done in 6C1 possible ways.
Sir, there
Right.
can be a case when two dark chocolates are drawn.
That is what I'm saying, that will not be the case, because the question says that probability that only one dark chocolate is drawn among those. It is not said that at least one dark chocolate. Okay.
Okay.
That's the difference.
Okay, sir.
So now we'll move to the next part of it.
Yes, sir, I have a doubt.
Yes. Say.
Here we can draw like the dark chocolate can be drawn in first attempt or in second attempt.
Okay. Yes. No, we are not considering about the order of picking up. Okay. Because it's ultimately, like for example, I may give you 2 chocolates, right? But does it matter that first chocolate what I've given you, was it a dark chocolate, or second chocolate was milk chocolate? Ultimately, you have 2 chocolates. Let it be 2 dark chocolates or 2 milk chocolates, or let's say 2 milk chocolates or 1 milk, 1 dark, whatever it is. That is what you are having as means the two types of chocolates. It doesn't matter which one was given to you first, which was one given to you second. So over in this case, order doesn't matter. We are ultimately just choosing two chocolates. That's it.
Yes, yes.
Okay. Others, please try to solve this one.
Done, sir.
Okay. Okay, so from here on, Farhat would be taking the class. Okay. So just try to submit your responses, then we'll move ahead with this solution.
Yes, good evening, everyone. Okay, everyone's done with the question. Anyone still solving it?
Done, sir.
Okay, is anyone still solving anyone? I can wait for a couple minutes more if anyone is still solving. Okay, I guess nobody is solving. Let's see the solution. So this is the second part of this question. You saw the first question. This one we were, okay, we had to find the probability of one dark chocolate among the two drawn chocolates. Now, what the question is saying, we have been given a box, there are 10 chocolates, 6 are milk and 4 are dark chocolates. Now again, 2 chocolates are drawn at random without replacement. What is the expected number of dark chocolates drawn? Okay, let's first see the solutions, responses. Okay, yeah, most of you have got this correct, 0.799 or 8. This is the correct solution. Anyone wants to share how they got this solution? Those who have got this solution in this range, 0.799 or 8.
Problem, the random variable can take 3 values, 0, 1, 2. And for 0, it would be 62 upon 10 C2. For 1, as we discussed earlier, 4 C1 into 6 C1 divided by 10 C2. And for 2, it would be 4 C2 upon 10 C2. After that, it's just expectation, calculating expectation.
Yes. So basically, what we have is, we have been given this, we have this one. So coming here. As I've also mentioned in the problem solving sessions, really, that we are already solving some questions that we know will either be, which will say in week 11 will be following binomial, Bernoulli or hypergeometric distribution. We already know how to solve them. So the solution has mentioned that like this follows a hypergeometric distribution. The formula for that is mn upon n. What this is, we'll see this in the upcoming week. For now, let me just share my screen and show you the solution for this. As I've also already mentioned, these concepts we have already solved. So this is the question. What was the what the question had asked? We had 10. Okay, we had 10 chocolates, right? 10 chocolates, and of those 10, 6 are milk chocolates. My screen is visible.
Yes, sir.
Okay. And 4 dark chocolates. Now, what we have to do is we have to calculate the expected number of dark chocolates.
Sir, are you sharing another screen?
Yes.
No, it's not visible.
I think it should be visible or not. It's visible. You can you're not able to see this one.
No, sir.
Is this problem same with everyone?
Yes, no. I can also not.
Yeah, we can see only that question slide which
Correct.
contained Q3. There is
Okay. What you can do is in the participants list you can pin my screen. Pin me to the screen.
It only shows your profile photo.
Okay, just
Write that. Hello, somebody speaking?
No.
Okay.
Now it's visible?
Yes.
Okay. So what we have been given 10 chocolates. Of the 10 chocolates, there are 6 milk chocolates and 4 dark chocolates. Now, what the question is that what is the expected number of dark chocolates drawn? How many chocolates we are drawing? We are drawing 2 chocolates, right?
Correct.
Okay. So let X denote the random variable that denotes the dark chocolates drawn. What values can X take? It can either be 0. We can, in the 2 chocolates that we draw, both can be milk chocolates, right?
Correct.
And then X will be 0, or it can be 1, or it can be 2. These are the 3 cases that we will have, right? Now
Yes,
we'll have to find the probability for these X taking the values Xi whatever. What is the probability that we will get both chocolates as milk chocolates?
6 C2 upon 10 C2.
Okay, 6C2 upon 10C2, right? What will be the probability? I think this question, probability of X taking 1, you just solved this.
Yes, sir.
It is 6 into 4C1 upon 10C2. One chocolate will be milk chocolate and one will be dark. And for X taking value 2, it will be 4C2 upon 10C2, right? Any doubts in to this part, anyone?
Yes, I have a
Yeah.
doubt.
Okay.
Here we are taking when random variable taking value x 0, then in numerator there is 6c2. So what is the difference between 6c2 and 5c2? 6c1 into 5c1. When we are doing like we have taken one chocolate from 6, again we have taken one chocolate from 5.
You mean to say like if I do this 6C1 into 5C1, this is what you're trying to see.
Yes.
So what does this mean?
We are taking one chocolate from 6 milk chocolate.
No, not forget this chocolate situation for a while. What does this mean? 6C1 into 5C1. How do you like?
We are taking two consecutively chocolates from without replacement.
Okay. So, okay. When you are doing this 6C1 into 5C1, let me say, suppose 6 chocolates were there. It would be first 6 upon 10, right? Then it would be, how much would it be in the second case? Huh?
5 upon 10.
Huh? Sorry?
5 even upon
5, okay, you are saying this 5 upon 10. Okay, but this is without replacement. Then what would happen? If it's without replacement, can you get this chocolate back? Can you get this chocolate back? When you're doing this, what we are saying is we are, if you can go to the question, the two chocolates are drawn at random without replacement, right? So when you are saying 6 divided by 10 into 5 divided by 10, you're just putting this chocolate back in, right? This won't be this. What we are dealing with is basically
it would be 5 upon 9.
Sorry.
5 upon 9.
Okay, 5 upon 9. What does this represent? Yes.
And probability of drawing the next milk chocolate.
Milk chocolate, yes. So basically this will be our 30 upon 90. Okay, this is right. This is also an approach to do so, but this is much easier approach to do this. You can also do this, but when you are dealing with, suppose there are this objects, these were simple right now, right? These were just 2. Suppose the number of, and this was just 6. Suppose if the number is changed, then it becomes easier to deal in this combination. Okay, this is also right. What you're doing is you're first drawing suppose there are 6 chocolates. So first, the probability of getting first chocolate as milk chocolate would be 6 upon 10, right? And then your probability of getting a milk chocolate would be 5 upon 9, since you have taken out one chocolate. Okay, that is also correct. That is also, this will give the same solution. What is this basically? This will be your 15 upon 45, and this is 30 upon 90. So this will
1
also
upon 3 both.
15 upon 45. So that is there. Okay, any doubts?
Yes, clear.
Okay, now up to this point, any other doubts, anyone?
No, sir.
So what we have done is we have just calculated the probability of this random variable taking the values 0, 1 and 2. Now if we solve this, this comes out to be, I think, 15 upon 45. This will be 24 upon 45, and this comes out to be 6 upon 45. Yes, so these are the values that we have calculated for the probability, respective probabilities. Okay, now we know what is our expectation. What is our expectation? It's basically the value the random variable takes xi into the probability, right?
Yes.
So it will be here, the random variable is taking the value 0, so it will be 0 into 15 upon 45. Yeah, 0 into 15 upon 45 plus 1 into 24 upon 45 plus 2 into 6 upon 45. So this comes out to be 24 plus 12 upon 45. That is our 36 upon 45, which is equal to 0.8. Okay. Any doubts in this question?
No, sir.
So here I have got the expected value. Understand? I got it. Here we can say that when we are talking about 6C2, then we are taking holding both in both hand two chocolates, and when we are doing 6C1 into 5C1, then putting one hand into the bag and taking one chocolate, again putting the hand from 5 taking one chocolate.
Yes, that is what, like when you're doing this, when you're doing this 6 upon 10 into 5 upon 9, what you are doing is first you are taking one chocolate out of 10. Then you are going again and you're taking one chocolate out of the remaining 9 chocolates. Okay. In the second, when we are doing this 6C2 upon 10C2, what we are basically doing is we are choosing 2 chocolates from the given 2 chocolates. Okay.
Okay.
So that's what also was mentioned in the, just a moment, let me start sharing from this. Just a moment. Okay, is the screen visible now?
Yes.
So we have seen that we are in a capacity to solve such questions, and in the further week we will see what we did. It was just following a hypergeometric distribution. As I've also mentioned in the sessions, for those who have been attending the problem solving sessions, I've always told that we have already been discussing these hypergeometric distributions, these binomial or Bernoulli trials, but we just don't know we are doing those right now. Similarly, this question we will see how we'll approach this using hypergeometric distribution. But the basics, in the basic method, how we solve it, is that clear to everyone?
Yes, sir.
Okay. Now moving to the next question. Okay, for all those that are posting their solutions in the chat box, I request you to join this periodic session. You can go to joinpd.com, and there you will have the option of joining the session, and it will ask for a code, and that this is the code, the one at the top right corner, QGUPTG. You can post your solutions there. Anyone still solving this question? Okay, let me rephrase that. Everyone is done? All those who are solving done with the question? Hello? Am I audible?
Yes, sir.
I'm done,
Yes,
sir.
yes. Yes.
Okay, okay. Take your time. Take your time. Just let me know when you all finish this, okay? So that I'll start discussing.
I'm done with the answer.
Okay, anyone still solving?
Done, sir.
Okay. Okay, now let's discuss the solution. The question goes like, the past records of a football club in a golden goal match are analyzed. Assume that the result of a match is independent of other matches. Okay. So what we have been given xi equals 0 with probability 0.4 and 1 probability 0.6, where x equals 0 if team loses and x equals to 1 means the team wins. Okay. What is the expected number of wins in 5 matches? Yes, just have a look at the solution. Okay, all solutions are 3. Would anyone volunteer to say how to solve this question?
Yeah. So this.
Final distribution.
Yeah. So this matches. If you look at there are finite number of trials and independent, and there are only 2 outcomes: success and failure.
Okay.
So this qualifies to be, a Bernoulli trial. The success is 0.6, 5 trials. So the result is 3.
Okay. Is Bernoulli trials discussed in week 10?
So
Bernoulli
Bernoulli
and random is
random
in
variable was discussed.
Sorry?
Bernoulli
Yes.
variable. Bernoulli variable was discussed.
Yes.
Okay. Okay, then it's fine. Okay. So this is the correct approach for this. We have been given this. There are 5. We have been given fixed number of trials, right? In 5 matches, we can look at them as 5 trials, right? So what we have been given the probability of one event and the other, success and failure. We can view them as success and failure, right? Lose we can will as failure or success, whatever one you want to see this. What is the expected number of wins? So our wins will be, we can consider this as success, right? Probability of success is 0.6 and probability of failure is 0.4. So how to calculate the expectation? So our expectation will be 0. What is failure into its probability plus success into the probability? That will be 0.6. So this is for 1, right? So for 5, it will be, if the number of trials are 5, n. So it will be n times this expectation of x, n times this. So it will be 5 into 0.6, that is 3, right?
Correct.
Okay. As I can see, most of you, no, everyone has got this correct. So I don't think any doubts are in this question. Can we? Should we move ahead?
Sure, sir.
So just a moment. Okay, so variance and standard deviation of a random variable. I think most of you would have gone through the lectures and watched them. So you know what a variance and standard deviation is. We know standard deviation is just the square root of variance. So what is variance? Expectation does not give us information about variation of spread of the data set, right? We have already seen this. We have been seeing this even in week 4. Why do we go for variance? Why don't we are not we content with mean or whatever? Then we saw that our mean does not always give us the entire information about the data set. Sometimes the two data sets, two entirely different data sets, tend to have the same mean, right? But then the data sets are two entirely different data sets. So what we go is we go for other measures. Like in week 4, we go for variance, standard deviation, all those. Similarly here, variance, what it tells us about the spread, how the data is spread, about the mean, how it's spread. Are more values towards one side, or are they towards the other side, or are they near the mean? So that is why we go for variance. So variance of a random variable, how we calculate variance of a random variable? We calculate the expectation of x square. So the x that we have, we square it and calculate its expectation, and from that we subtract the expectation of x that we get, its whole square. So that is our variance. That is how we calculate our variance. And we have already seen what standard deviation is. It's just square root of our variance. So that is all for the standard deviation and variance. I don't think there will be any doubts from this, or are there any doubts? Okay, now let's proceed. So this is the next question. Okay, someone is mentioning they have doubt in some activity question. I suggest you to join those doubt clearing sessions or problem solving sessions. You can ask your doubts there. Is everyone done with the solution?
Yes, sir.
Okay. Anyone still solving? I think I've given enough time for this question. This is half of this question we already have calculated. We just okay. Now what do we have? We have the same question, but now what it has asked is that we need to calculate the variance of number of wins in the 5 matches. We have already calculated the expectation. Now what we are left to calculate, we have calculated E of X. What we are left to do is calculate E of X square, right? So for that, what we will do, we'll just square these X values, that is 0 and 1, and multiply by this with the respective probabilities, that is 0.4 and 0.6. So first let's have a look at the responses. 1.2 is the correct for this. Yeah, yes. I think most of the responses are there at 1.2. Okay, now let's see how this is. So expectation of X we've seen, this is 0.6, and expectation of X square, we'll just square these X values. That is 0 square into 0.4 plus 1 square into 0.6. That is again 0.6. So variance of X is expectation of X square minus expectation of X whole square. So that is 0.6 minus 0.6 whole square. That comes out to be 0.24. This is for one single, right? Now we have how many matches are there? 5 matches, right? So what we will do is we'll just basically multiply this with 5 times, right? This will be summation of 5 times. So that is 5 multiplied by 0.24. That is 0.2. Sorry, 1.2. And I think most of you have got this correct as 1.2. There are a few responses. Okay, they are in this range now only. Okay, any doubt in this question? I think if you're like very well versed with the previous weeks, you won't have much doubts in these weeks because they've already solved such questions. We're just now getting to know how we classify them, what we call those. Okay.
The variance of that variable.
Sorry?
If you calculate the variance for that binomial variable, Bernoulli variable, and if we if we change that to the variance of 5 matches, shouldn't we multiply with 5 square?
Sorry? No, this is right. This is basically summation. One match plus another match. That becomes 5 times. I meant to say 0.5 plus 0.5 times. It becomes 5 times. No? That's what I meant to say. Okay, this question, this is pretty simple. These are just properties, right? These are properties of expectation and variance. Okay. 10 responses. 1 and 2. Okay. 1 and 3. Okay. So is anyone still solving this? Okay. So what this question is basically, it follows from the properties of expectation and variance, right? We've seen that expectation of y, if y it's multiplied, it will also be multiplied, and if we have added a constant, it will also reflect in the expectation, right? if there is some random variable x and it is of the form s, and if we multiply, there is another function, say y, that is of the form as plus b. So the expectation of if the expectation is, I mean to say, if the expectation of x was s, the expectation of y will be a times expectation of expectation s plus b, right? That this is directly from the properties that we have studied. And for variance, what happens basically in variance, we also seen this in week 4. Can you correlate? Can you somehow correlate it? In week 4, when we were seeing the effect of adding a constant and multiplying a constant to a variance, standard deviation, mean, all those, we saw the effect of adding a constant. It's not there on the variance, right? We've already seen this in week 4. So here also it follows the same thing that sorry. Is someone saying anything? Hello?
No, sir, I don't think.
Okay. So
No, sir, you just continue.
So from that same explanation, we can see, and we have also studied in this week, that variance of y will be the this a square times variance of s, right? So from this explanation, 1 and 3 are the correct options. These are the just properties that we have studied for expectation and variance in this week. And this was just a simple question from that only. And I think most of you have done this correct. 1 and 3. There were a few responses, 2 responses for 1 and 2. So I think this is clear. Any doubts in this?
No, sir. No, sir.
So I think this is all for today's session. Okay. There isn't as you can see that most of these questions we have already discussed, or we know how to approach them. Now we are just formalizing what we have already studied into some other topics, right? These questions, we were also solving the same questions earlier as well, like drawing 2 milk chocolates. We were solving that before as well, but now we're just classifying them as hypergeometric, whatever, binomial, Bernoulli, whatever these distributions are. But in the sense, we already know what is happening, how we are approaching these questions. Okay.
Yes,
we'll just get more familiar with them in week 11 and week 12. So that is this is all for today's session. And for others who have any doubts, they can either post them on the discourse discussion forum, or they can join the doubt clearing sessions that are there daily. Okay. That is the purpose of those sessions. The doubt clearing and problem solving is there. So
one small thing.
Yeah.
Did you discuss that question regarding that choosing 2 different numbers from 1 to 9, and how many 3-digit number can be made if repetition is allowed?
Can you repeat this?
So the question was that how many 3-digit numbers can be formed using 2 different digits from 1 to 9 if repetition is allowed?
Okay. Can you do you have access to this discussion forum and discourse?
No, sir, I don't. Actually, I discussed it with Rajkishore sir in the 3 p.m. session.
Okay.
And we could not agree on the solution. So sir said that maybe we can discuss with that question with Mayur sir. And so I was just checking if you guys have discussed that question with the Mayur sir.
I didn't have any knowledge up to this point about that. I'll surely talk to Rajkishore about the question, and I'll let you know tomorrow. Okay. In
Sure.
the session.
So in the answer sheet, the answer was given 216.
Okay.
But for me, the answer comes out to be 288.
Okay.
So
yeah. We'll just discuss this tomorrow. You are regular to the sessions. We'll discuss it there. Okay. I'll just discuss with Rajkishore what the question is. Then I'll see. We'll just discuss the solution as well, and we'll let you know tomorrow morning.
Sure.
Tomorrow morning or evening session, whichever one. Okay.
Sure.
Sir, and that IQR question in the Q2.
There is a mistake in that. The IQR has to be 8, but it's wrongly marked as 9.
Okay.
You don't worry about that. It will be considered. There is some mistake, typing error is there. So 8, if you've got 8, that is the correct answer for that. No need to worry.
Sir, why 8? Because why 0 won't be considered?
Sorry?
Why 8, sir? 9 was correct, right?
No, 9 is not correct because there is no 0 there. The data set is given -3, -2, 4, 6, and something like that.
Okay.
So what comes out to be?
It was not like a number line.
No, it was not like that. So what comes out to be, our IQR has to be 6 minus -2. That is 8, but somehow it has been marked as 9.
Sir, it should have to be arranged in the ascending order. That's why the order was something.
Maybe they might have missed that because of like a silly mistake might have occurred there. But it's 8. We have confirmed that. So that's 8. So no need to worry about that question. Okay.
Okay. Thank you, sir.
Okay, sir. Thank you.
Okay. Goodbye, everyone.
Sir, if you have a minute, sir, just if you have just a minute, right? So if data point is 0, assume, right? Other is -2, then difference is still 2, right? Suppose 75 percentile is 0 and 25 is suppose -2. The difference is still 2, right? But so why we so the interquartile range is the whole range, right? The gap between 75th and 25th percentile, because the numbers are such a way, the data is such a way that it accommodates negative and positive number, which means the 0 will also be a valid number in between, right?
Not necessarily. So suppose if I have data that I have number of cars, let us say, okay, number of cars that that cannot be negative, of course. So suppose there is some data that can take negative values as well, okay. So
but
0
it cannot take 0, is it?
No, it's not necessarily. See, when we have been given the data, right, we cannot assume anything on our own. We don't know what the data is corresponding to, right? So
those were recorded observations.
Those were recorded observations. Until and unless we don't know what the data refers to, we cannot say is this possible or is this not possible. So what it was simply asking us, you have been given these 5 or 6 data points were there. 5, I think there were 5 data points. Just calculate its IQR. It was pretty simple question. We didn't have to think is 0 will be there or not. It was said that these 5 observations have been recorded. So whatever was recorded, we will only consider those, right? With following the same logic, I can introduce 0 in every question. Then I will say, okay, 0 is in every question, right? Then it will just, it won't make sense. Suppose there is another question in which my data points are 1, 2, 3, 4, so on, -7. I will say, okay, 0 is not there, but it has to be there since it is ranging from negative to positive. So 0 must be there. Is that the case? Suppose my data is from 25 to, my range is from 25 to 70. Is it necessary that 30 will be a data point there? No, it's not.
No, I'm not talking about that, sir. But data type, when we say data type, it looks like an integer, right? There is no such data type where we have only negative and positive without 0.
Yeah,
either we have a positive numbers or we have a integer, right? So
I think you got it a bit wrong, because say if you are taking observations and you only got 5 observations, you cannot add 6 observation on your own, right?
No, I'm not adding 6. It's a range, right?
No, it's not a range.
IQR
Those
is the range
discrete.
between
IQR is a range.
Yeah.
IQR is a range, but those observations are discrete values. And when we find the IQR, it's a range. You got that part correct. So the range comes out to be 8, and that 8 also includes 0 in it.
Okay. Does it include -2?
Yes. -2 to 6 was it? So it's a range of 8, correct? So 0 is ultimately included in that.
So like
you're right. Actually, you're right.
For calculating, you don't need to see that. What we were given is we just need to calculate IQR. We weren't considered with what range it is spanning. We just needed to calculate the IQR that was there.
Correct, correct. I got it. Thank you.
Okay, any other doubts? And if you have such doubts, you can always post them on the discussion forum, discourse, or join the doubt clearing session.
Sure, I'll do that. Thank you.
Okay. Okay, thank you, everyone. We'll end
Thank you
this
so
session.
much, sir. Have a good night.
Good night, everyone. Goodbye.